Media. Transmission media is a communication channel that carries the information from the sender to the receiver. Data is transmitted through the electromagnetic signals. The main functionality of the transmission media is to carry the information in the form of bits through LAN, local area network. It is a physical path between transmitter and receiver in data communication. In a copper-based network, the bits in the form of electrical signals. In a fiber-based network, the bits in the form of light pulses. In OSI, Open System Interconnection, phase, transmission media supports the Layer 1. Therefore, it is considered as a Layer 1 component. The electrical signals can be sent through the copper wire, fiber optics, atmosphere, water, and vacuum. The characteristics and quality of data transmission are determined by the characteristics of medium and signal. Transmission media is of two types: wired media and wireless media. In wired media, medium characteristics are more important, whereas, in wireless media, signal characteristics are more important. Different transmission media have different properties such as bandwidth, delay, cost, and ease of installation and maintenance. The transmission media is available in the lowest layer of the OSI reference model, i.e., physical layer. Some factors need to be considered for designing the transmission media. Bandwidth. All the factors are remaining constant. The greater the bandwidth of a medium, the higher the data transmission rate of a signal. Transmission impairment. When the received signal is not identical to the transmitted one due to the transmission impairment. The quality of the signals will get destroyed due to transmission impairment. Interference. An interference is defined as the process of disrupting a signal when it travels over a communication medium on the addition of some unwanted signal. Causes of transmission impairment in communication system. Analog signals travel through transmission media, which tends to deteriorate the quality of analog signal, which means that the signal at the beginning of the medium is not the same as the signal at the end of the medium. The imperfection causes signal impairment. Below are the causes of the impairment. Attenuation. Attenuation means the loss of energy, i.e., the strength of the signal decreases with increasing the distance, which causes the loss of energy. Amplifiers are used to amplify the attenuated signal, which gives the original signal back and compensate for this loss. Attenuation is measured in decibels, dB. It measures the relative strengths of two signals or one signal at two different points. Attenuation, dB, equals 10 log 10, P2/P1. P1 is the power at sending end and P2 is the power at receiving end. Sum with a decibel is also defined in terms of voltage instead of power. In this case, because power is proportional to the square of the voltage, the formula is attenuation, dB, equals 20 log 10, V2/V1. V1 is the voltage at sending end and V2 is the voltage at receiving end. Distortion. Distortion occurs when there is a change in the shape of the signal. This type of distortion is examined from different signals having different frequencies. Each frequency component has its own propagation speed, so they reach at a different time, which leads to the delay distortion. Noise. When data is traveled over a transmission medium, some unwanted signal is added to it, which creates the noise. There are several types of noise, such as induced noise, crosstalk noise, thermal noise, and impulse noise, which may corrupt the signal. Induced noise comes from sources such as motors and appliances. These devices act as sending antenna and transmission medium act as receiving antenna. Thermal noise is movement of electrons in wire, which creates an extra signal. Crosstalk noise is when one wire affects the other wire. Impulse noise is a signal with high energy that comes from lightning or power lines. Classification of transmission media. 1. Guided media. It is defined as the physical medium through which the signals are transmitted. It is also known as bounded media. A signal traveling along any of these media is directed and contained by the physical limits of the medium. Twisted pair and coaxial cable use metallic, copper, conductors that accept and transport signals in the form of electric current. Optical fiber is a cable that accepts and transports signals in the form of light. Types of guided media. 1.1. Twisted pair cable. Twisted pair is a physical media made up of a pair of cables twisted with each other. A twisted pair cable is cheap as compared to other transmission media. Installation of the twisted pair cable is easy, and it is a lightweight cable. The frequency range for twisted pair cable is from 0 to 3.5 kHz. A twisted pair consists of two insulated copper wires arranged in a regular spiral pattern. A twisted pair consists of two conductors, normally copper, each with its own plastic insulation, twisted together. One of these wires is used to carry signals to the receiver, and the other is used only as ground reference. The receiver uses the difference between the two. In addition to the signal sent by the sender on one of the wires, interference, noise, and crosstalk may affect both wires and create unwanted signals. If the two wires are parallel, the effect of these unwanted signals is not the same in both wires because they are at different locations relative to the noise or crosstalk sources. This results in a difference at the receiver. The degree of reduction in noise interference is determined by the number of turns per foot. Increasing the number of turns per foot decreases noise interference. Types of twisted pair. A. Unshielded twisted pair. An unshielded twisted pair is widely used in telecommunication. It is the most common type of telecommunication when compared with shielded twisted pair cable, which consists of two conductors, usually copper, each with its own color plastic insulator. Identification is the reason behind colored plastic insulation. UTP cables consist of 2 or 4 pairs of twisted cable. Cable with 2 pair use RJ11 connector, and 4 pair cable use RJ45 connector. Following are the categories of the unshielded twisted pair cable. O Category 1. Category 1 is used for telephone lines that have low-speed data. O Category 2. It can support up to 4 megabits per second. O Category 3. It can support up to 16 megabits per second. O Category 4. It can support up to 20 megabits per second. Therefore, it can be used for long-distance communication. O Category 5. It can support up to 200 megabits per second. Advantages of unshielded twisted pair. O. It is cheap. O. Installation of the unshielded twisted pair is easy. O. It can be used for high-speed LAN. Disadvantage of unshielded twisted pair. O. This cable can only be used for shorter distances because of attenuation. B. Shielded twisted pair. A shielded twisted pair is a cable that contains the mesh surrounding the wire that allows the higher transmission rate. This cable has a metal foil or braided mesh covering which encases each pair of insulated conductors. Electromagnetic noise penetration is prevented by metal casing. Shielding also eliminates crosstalk. Characteristics of shielded twisted pair. O. The cost of the shielded twisted pair cable is not very high and not very low. O. An installation of STP is easy. O. It has higher capacity as compared to unshielded twisted pair cable. O. It has a higher attenuation. O. It is shielded that provides the higher data transmission rate. Disadvantages. O. It is more expensive as compared to UTP and coaxial cable. O. It has a higher attenuation rate. O. Difficult to manufacture. Applications of shielded twisted pair cable. In telephone lines to provide voice and data channels. The DSL lines that are used by the telephone companies to provide high data rate connections also use the high bandwidth capability of unshielded twisted pair cables. Local area network, such as 10BASE-T and 100BASE-T, also use twisted pair cables. 1.2 Coaxial cable. O. Coaxial cable is very commonly used transmission media. For example, TV wire is usually a coaxial cable. O. The name of the cable is coaxial as it contains 2 conductors parallel to each other. O. It has a higher frequency as compared to twisted pair cable. O. The inner conductor of the coaxial cable is made up of copper, and the outer conductor is made up of copper mesh. The middle core is made up of non-conductive cover that separates the inner conductor from the outer conductor. O. The middle core is responsible for the data transferring, whereas the copper mesh prevents from the EMI, electromagnetic interference. Coaxial cable is of 2 types. A. Baseband transmission. It is defined as the process of transmitting a single signal at high speed. This is a 50 ohm, omega, coaxial cable, which is used for digital transmission. It is mostly used for LANs. Baseband transmits a single signal at a time with very high speed. The major drawback is that it needs amplification after every 1,000 feet. B. Broadband transmission. It is defined as the process of transmitting multiple signals simultaneously. This uses analog transmission on standard cable television cabling. It transmits several simultaneous signals using different frequencies. It covers large area when compared with baseband coaxial cable. Advantages of coaxial cable. O. The data can be transmitted at high speed. O. Used in long-distance telephone lines. O. Much higher noise immunity. O. Data transmission without distortion. O. It has better shielding as compared to twisted pair cable. O. It provides higher bandwidth. Disadvantages of coaxial cable. O. It is more expensive as compared to twisted pair cable. O. If any fault occurs in the cable causes the failure in the entire network. Applications of coaxial cable. Coaxial cable was widely used in analog telephone networks, where a single coaxial network could carry 10,000 voice signals. Cable TV networks also use coaxial cables. In the traditional cable TV network, the entire network used coaxial cable. Cable TV uses RG59 coaxial cable. In traditional Ethernet LANs. Because of its high bandwidth and consequence high data rate, coaxial cable was chosen for digital transmission in early Ethernet LANs. The 10BASE-2, or Thin Ethernet, uses RG58 coaxial cable with BNC connectors to transmit data at 10 megabits per second with a range of 185 m. 1.3 Fiber optic cable is a cable that uses electrical signals for communication.